Hi everyone, welcome to day 4 of Week of Continuous Intrusion Tools. Day 4 deals with common abuse set of all the CI tools we have discussed yet, couple of post-exploitation and lateral movement scenarios. The blog post of day 4 lists or creates a common abuse set by summarizing all the poor design and implementation issues we have seen in first 3 days. So things like lack of defense against brute force attacks, storage of SSH keys in plain, high privileges of services of CI tools on Windows machines, etc. are detailed in the blog post. The blog post also lists or there are details on the blog posts about lateral movement and post exploitation, and we are going to discuss both of them in this video as well. So here is the scenario at hand. We have access to a Jenkins instance as a configuration level user. That is, we have the ability to configure builds. Keep in mind that we are using Jenkins just for example. Any CI tool will allow us to do the same things. Now, even if the master runs on Linux machine, there are almost always slaves which run on Windows machines, and that too with system privileges. So what we are trying to do is we want to enumerate tokens available on all the machines, all the Windows slaves, and we want to try and see if there is any token of a high privilege user on such a machine. So let's quickly see this sample here. What we want to do is we want to enumerate all the tokens using the invoke token manipulation PowerShell script from the PowerSploit project. We are just downloading and executing it in memory. So let's quickly build this. So we are making an assumption that we know we know who are the domain administrators and which machine is the domain controller. So these things are really trivial to find out, so I'm skipping them. So as you can see, we have a token of network service, system, a domain user, and a domain administrator as well, which is quite good. Note the process ID associated with this token is 988. So let's go back and change the command we are executing on this slave. Note that because this is my lab machine, we had the access immediately. Otherwise, we may need to run it on much more number of Windows slaves. But this works so many times that if you try it on a red team engagement or a penetration test, you will be pleasantly surprised. So now what we are trying to do is we will once again download the script in memory and execute it in memory as well. Using the process ID of the process with domain administrator token, we are impersonating it, and after impersonating the token, we want to run this command called get process on the domain controller machine. So let's see if this works. Let's just manually trigger the build, and now if we see the console output, we can see that the script was downloaded and we were able to successfully emulate the PFPT lab administrator, and this is very nice. We were able to run commands on domain administrator. Now, if you recall, we can always run reverse shells here as well using PowerShell. So if we can communicate with the domain controller directly, we can simply have a reverse shell on the domain controller itself with domain admin privileges, which is quite good, but scary as well. So this was actually one of the scenarios where we just moved on to domain admin from a system user. Another interesting thing is the number of credentials for Linux machines which are available in a Jenkins instance is very scary. So if you recall, when we used the decrypt credential, we saw this decrypt credential scenario. We had a, I think I just ran this for this demonstration. Okay, we had a private key here. Okay, let me just quickly run this. Okay, we had one of the private keys here with this username and this passphrase. So as we saw earlier, we can just decrypt this and use this key. The only thing here is we do not know on which machine this key works. So for that, either we need to go through the build logs to see if we can find traces of this key or something similar somewhere, or we can just try it out on every Unix machine which we can access. If it is, if we are able to, if we have enough time, or if we are able to enumerate the machines. Obviously, for that to do that, to try it on all Linux machines, we first have to run things like nmap, etc. But I'll leave that to up to you. So let's just. I've already copied credentials.xml and both the keys here. So let me just quickly run. In fact, I think I've run that already. So if I run this now, so key pass is, I think this is a modified one. Let me just quickly uh, copy one from here. And if I run this now, you can see that we have credentials, we have passphrases and passwords here. Note that because this was the last one in the complete category, or in the complete credentials.xml file. So this one is key pass. As you saw a couple of minutes back, while testing, I removed other entries. So we can do that as well, just to see if, just to decrypt a particular encrypted passphrase. So this is the key pass, and this is our key. So let's just copy the complete key. Let's save it as Ubuntu. Let's just save this, and now we can either use that in the existing format, or to use it with PuTTY, we can just use this file, use the passphrase key pass, and we can save the private key. uh, key. Let's just overwrite the existing one. And now let's just quickly try to use that key. Now this is the part where I assumed things. We didn't knew that on which machine this key will work, so we may have to just throw it on all the machines in this subnet of the current slave, or on all the slaves or all the machines we have access to. So, but we know the username from credentials.xml. Oh, I made a typo here, so let's run again. Let me just quickly load it. So I believe that was the username, Ubuntu admin. It again asks for the phrase, which is key pass, and we have been able to log in on this Linux machine as well. So which is quite good. We can actually access machines using this thing. This is just not at all a theoretical retrieval of passwords. And in production, you will see so many private keys for root users here that it is actually mind-boggling to see how people can just throw away their private keys, especially for root, on systems like Jenkins, which actually don't know how to handle such sensitive data. So I think that is all for the post-exploitation part. Obviously, we can do so much that I can spend literally days discussing how and what we can access. Imagine someone grabbing a root of version control system or private repositories. So it's huge, and it's fun to do in penetration tests. So try these things out and share your pen test stories with me. So I think that is all. Hope you enjoyed it. Uh, okay, yes, that is all. Hope you enjoyed the video. Have a good day.